Recall Maxwell's equations in vacuum. First, del dot E, rho over epsilon naught. Number 2, del dot B, this is 0. So 3, Faraday's law, del cross E. This is negative partial B, partial T. And last, we have the modified Ampere's law, del cross B equals mu naught J plus mu naught epsilon naught partial E partial T. Now, ang problem na gusto nating isolve is given the charge. So given the charge, the charge distribution rho of xt and current density J of xt, what are the resulting electric fields and magnetic fields? Or vice versa. Diba? Kasi class, ang problem natin dito, kapag meron kang time-dependent charge distribution o kaya time-dependent na current distribution, time-dependent na rin syempre yung electric and magnetic fields natin. So kunwari, meron kang switch, di ba? At time 0, hindi mo pa in-on yung switch. Pero kapag in-on mo yon at time greater than 0, magkakaroon ka na ng current. So time-dependent yung current mo. And therefore, yung electric and magnetic fields mo, time-dependent na rin. So before class, di ba, sa static case, sa electrostatics, E equals negative del V. Ayan sa electrostatics. And nasulat natin to dahil, so because del cross E equals 0. Diba? Yung curl ng electric field natin sa electrostatics, 0. Therefore, pwede natin siyang isulat as a gradient of some scalar potential. Pero this is not true for electrodynamics. Sa dynamic case, kasi yung del cross E mo sa dynamic case, negative partial B partial T na. So not necessarily 0. Therefore, itong del cross is 0, not true for electrodynamics. And itong E equals negative del V, not true for electrodynamics. Pero, on the other hand, sa magnetostatics, di ba, meron tayong B is del cross A. Yan yung ating magnetic field sa magnetostatics. Bakit? Sinet natin na del dot B equals 0. Kung curlless yung vector mo, you can write it as a curl. Kung divergence-less ang vector mo, you can write it as a curl of some other vector. Pero, itong del dot B equals 0, totoo ba siya even for electrodynamics? So yes, totoo pa rin. So in the dynamic case, this is also true. Ay, still true for electrodynamics. So yan yung ating electric and magnetic field in the static case. Now, let us start. Start tayo with ito. B equals del cross A. So ito class, yung equation na to, B equals del cross A, still applicable for the electrodynamic case. So how about the electric field? Paano natin i-express yung electric field in terms of the potential? So ito static lang to, di ba? Hindi natin alam kung ano yung sa dynamic. So what we'll do, gamitin natin tong Faraday's law, yung Maxwell equation 3. So from Maxwell equation 3, let us write del cross E equals negative partial B partial T. Pero ang B natin ay ito, del cross A. So this is negative partial T ng del cross A. So this is del cross E. Now, itong temporal and spatial, pwede nating interchange yan, di ba? So this is equal to, ano to? Negative del cross partial A partial T. Ayan. So, pareho na siyang curl. Pwede nating pagsamahin lahat sa left-hand side. So, magkakaroon tayo ng E plus partial A partial T. So, del cross E plus partial A partial T, this is equal to 0. So, nilagay ko na to sa kabila. Pareho silang curl, so pinagsama ko na lang sa isa. At dahil 0 yan, ito, the curl vanishes, di ba? So here we can see that the curl vanishes. So kapag 0 ang curl, take note, kapag 0 ang curl, pwede mo siyang isulat as a gradient of something. So it can be written as a gradient of a scalar. Ayan. Kapag 0 curl, gradient siya ng isang scalar. Bale, yung etong vector natin na E plus partial A partial T can be written as a gradient of some scalar V. So, ito na yung bagong potential natin. Bale, therefore, yung ating electric field i-isolate natin, E equals negative del V minus partial A partial T. Ito na yung ating electric field in the electrodynamic case. So this is the electrodynamic case. So ayan na, meron na tayong E in terms of the potential. 'Di ba class, kapag static case tayo, wala kang hindi gumagalaw ang charges mo. So E is negative del V kapag static. Pero in general, electrodynamic, meron kang term na partial A, partial T. Yun yung Itong B, hindi yan nagbabago, del cross A pa rin. So, itong electric field in the electrodynamic case, meron kang additional na term, negative partial A, partial T. So, bale, after that, let's take the divergence of both sides. So, take the divergence of both sides. So, ano to? Del dot E. Ito ay equal sa negative del ng gradient. Del dot del V. Ayan, nilabas ko na yung negative. Minus del dot partial A, partial T. Del dot partial A, partial T. Pero class, ang del dot E, di ba, yan ay rho over epsilon naught. Yan, from Maxwell equation 1, Gauss law. Rho over epsilon naught is equal to, ayan, negative del squared V lang yan. Del dot del. Minus, yung temporal class, ilabas natin, partial T, del dot A. Ayan. Bali, meron tayong equation, itong del squared V, tsaka ito ilipat natin sa kabila, tapos ito ilipat natin sa kabila. So, meron tayong del squared V plus partial T ng del dot A. This is equal to negative rho over epsilon naught. So, class, kamukha niya yung Poisson equation, di ba? Di ba yung Poisson equation natin dati, del squared V equals negative rho over epsilon naught. Yan yung Poisson equation. Pero in the electrodynamic case, you have this differential equation. So quote-unquote, ito yung Poisson equation in electrodynamics. So electrodynamic case. Yan na siya. Yung electrodynamic case plus time dependent na yung mga bagay-bagay natin. Kaya ka merong partial T dito sa electric field, 'di ba may partial T ka dito? Dito rin sa modified Poisson equation. Now, kung nagawa natin to sa scalar potential, pwede rin natin siyang gawin sa vector potential. So let us use, so recall Maxwell equation 4. Bale, ano to, del cross B. This is mu naught J plus mu naught epsilon naught partial E partial T. So yan yung ating Maxwell equation 4, yung ating modified Ampere's law. So what we'll do is take the curl of both sides. Ay, hindi pala. Wag muna. Itong B, pwede natin yang isulat as del cross A, di ba? So del cross A is equal to mu naught J plus mu naught epsilon naught partial T. Ano tong electric field natin? Ito. Diba yan yung electric field natin in the electrodynamic case. Negative del V minus partial A partial T. Balik class ang del cross. Wait lang. This is equal to mu naught J minus mu naught epsilon naught del of partial V partial T. Again, itong temporal at spatial derivatives, pwede nating pagpalitin yan. Tapos, minus mu naught epsilon naught, isang partial T, therefore, partial squared T siya. Partial squared A, partial T squared. Now, itong del cross A, di ba ito ay del dot A minus del squared A. Yan yung ito yung curl of a curl. So this is equal to mu naught J minus mu naught epsilon naught del of partial V partial T plus minus mu naught epsilon naught partial squared A partial T squared. Now ang gagawin natin, gawin nating positive. Class A, mag-multiply tayo ng negative 1 both sides. So negative, positive, positive yan, then positive to. Bakit natin ginawa yan? Kasi i-isolate natin yung lahat ng to, i-isolate natin dito sa kabila. Yung right hand side ay mu naught J lang. So we have del squared A, so ito yon minus, di ba, plus yan. So kapag nilipat ko sa kabila, minus mu naught epsilon naught partial squared A partial T squared. Ito yon minus the gradient of del dot A. Ito yon del dot A. Tas gradient din nito. Bali plus. Kasi may minus ka na. Minus na yan. So magiging plus siya. Plus mu naught epsilon naught partial V partial T. This is equal to negative mu naught J. So class, ito yung modified Poisson equation sa natin, sa magnetic field or sa so may vector potential natin. So this is your quote-unquote Poisson equation electrodynamic case. Diba dati yung Poisson equation natin sa magnetostatics, del squared A equals negative mu naught J. Yun lang siya. Pero sa electrodynamic case, yan na yung ating bagong equation. So saan ba natin ma-apply yung mga yan? Mag-example tayo, class. So let's do an example. So the problem, find the charge. Find the charge and current distributions. So bale, find rho and find J. That would give rise to the potentials given by the following. So V equals 0 and A equals mu naught K over 4C times Ct minus absolute value of X squared K hat. So this is for absolute value of X less than Ct and 0 for absolute value of X greater than Ct. So yan yung tanong. Ano yung rho at ano yung J na mag-yield ng ganitong potentials? So where K is constant and syempre yung C yung speed of light 1 over square root of mu naught epsilon naught. Speed of light in vacuum. So find rho and J. Bale, paano natin siya magagawa? So i-break down natin siya class. Step 1, ang gagawin natin, find E and B in terms of the potentials. Bali, yan yung unang step natin. Ano ba yung E and B natin in terms of the potentials? 'Di ba? Yan. Tsaka B is del cross A. So recall natin that E equals negative del V minus partial A partial T at tsaka B equals del cross A. So yan yung ating electric and magnetic fields in terms of the potential. So syempre, for X greater than Ct, ano ba yung X greater than Ct? 0 na yan, di ba? A and V are 0. E is 0 and B is 0. Kasi gradient ng 0 minus time derivative ng 0, 0 yan. Tapos curl ng 0, 0 din. So walang electric field and magnetic field for X, absolute value of X greater than Ct. Now, for absolute value of X less than Ct, ano meron tayo? E equals negative del of 0, kasi 0 to all the time, yung V. Minus, ano ang partial T neto? I-mental na lang natin ha. So, bali, bababa yung 2, tapos time derivative ng loob ay C. So, bali, mu naught K over 2. So, magiging mu naught K over 2 Ct minus absolute value of X. So, 1 na yan, K hat. Okay, class, minental na natin yung derivative ha. Bale, yung 2, bababa dyan. Tapos, chain rule, yung C. Magka-cancel yung 2C. Then, bale, wala na yan. So, ang electric field natin, mu naught K, ito lang, mu naught K over 2. Then, on the other hand, the magnetic field equals del cross A. Ano bang magnetic field sa, yung curl? Medyo, medyo mahaba yung curl, no? Partial Y, I hat. So, isulat ko lang yung curl sa Cartesian. AZ minus partial AX, partial Z, J hat, plus partial AX, partial Y, minus partial AY, partial X, K hat. So, yan yung curl. Bale, ano ba ang component ng ating vector potential? K hat lang. So, lahat ng Z. So, lahat ng hindi Z mawawala. Lahat ng hindi AZ. Ayan. So, anong partial AZ, partial Y? Hindi to Y dependent. So, 0 din. Matitira partial AZ, partial X. Which is, eto. Partial X ng, ano ta? Mu naught K over 4C. Ct minus absolute value of X squared J hat. So J hat na yan. Bale class, ang weird yung absolute value, no? Ito ay bakit? So this is equal to ano siya? Mu naught K over 4C 2 times Ct minus absolute value of x raised to 1 multiplied by kung ano yung nasa loob. Ito. Multiplied by yung derivative neto is -1. Tapos, yung absolute value of x natin, ito ay, teka nga lang, ang Ct minus x, if x greater than 0, Ct plus x, if x less than 0. Di ba yung absolute value, it works this way. Ct minus x yan, hindi magbabago if x is greater than 0. Tapos Ct plus x. Ct plus x if x less than 0. So tanggalin ko nga itong -1. Nakakalito. Therefore, ito ay minus plus. Kasi yung derivative neto is -1 or +1. Depende if x is greater than 0 or x is less than 0. So, ayan siya. Kaya yung ating, ano ba to? Wait nga lang, may negative pa pala dito sa labas. Ayan. Tama ba? So, yung negative ilalabas ko dito. Dahil dyan. Tapos, yung absolute value of x mo. So, that is the magnetic field. Tama ba? May minus plus pa. Okay. So, this is equal to, simplify ko nga, bali ito plus minus na lang. Kasi negative, i-multiply mo dun sa dalawa. Magiging plus minus. So, ito ay plus minus mu naught K over 2C Ct minus absolute value of x. Yan na siya. J hat. So, J hat. J hat. Yan na yung magnetic field natin. So, we obtained the electric and magnetic field in terms of the potentials. So, step 2, find rho and J. Find rho and J using Maxwell's equations. So, yun na yung step 2 natin. Bale, paano mo ba malalaman yung rho and yung J? Gagamitin natin yung equation na may rho at yung equation na may J. So, yung dalawang yan. Una, di ba, ano to? Del dot E equals rho over epsilon naught. Tapos, del cross B equals mu naught J plus mu naught epsilon naught partial E partial T. Yan yung dalawang equation na gagamitin natin. Now, for x, absolute value of x greater than Ct, di ba ang electric and magnetic field natin ay 0. Ayan. So, 0 equals rho over epsilon naught, rho equals 0. Tapos, yung isa magnetic field mo, 0 rin. So, 0 equals mu naught J plus mu naught epsilon naught. Ang electric field mo, 0 rin. Therefore, J is 0. So, for absolute value of x greater than Ct, rho is 0 and J is 0. Yung interesting case is for absolute value of x less than Ct. So, bale, yung unang equation natin, ito yung electric field natin, di ba? Bale, gagamitin natin yan. Del dot E, which is negative mu naught K over 4 Ct minus absolute value of x squared k hat equals rho over epsilon naught. Yan yung ating ano ba to? Yung delta t equals rho over epsilon naught. Pero ano ba ang divergence? Anong divergence class? 'Di ba? Partial xi hat plus partial ax partial x partial ay partial y partial az partial z. Yan yung divergence, 'di ba? Ito ay z component lang, k hat. So ano yung partial z neto? 'Di ba? Hindi siya dependent sa z kasi x lang 'yan. Therefore, yung divergence neto 0. 0 is rho over epsilon naught or rho equals 0. So puro 0 yung nagiging result natin, no? Itong isa naman, yung ating j, ano ba yung magiging j natin dito? Yung isa del cross b equals mu naught j plus mu naught epsilon naught partial e partial t. Bale, ang del cross b natin, ito, del cross plus minus mu naught k over 2c ct minus absolute value of x, wala nang squared, j hat, this is equal to mu naught j plus mu naught epsilon naught partial t nung electric field natin, which is negative mu naught k over 2 ct minus absolute value of x k hat. Yan yung ating Ampere's law, modified Ampere's law. Now, ang curl neto, this is, shortcut ko na lang class ha. Diba? Ito siya. Ito ang curl. Sige, isa-isahin natin. Siya ay j hat lang. So, ay lang. Ito lang. At ito yung meron tayo. The rest ay hindi. Ito pala. The rest ay 0 na. So, partial ay, partial z, 0. So, wala na tong term na to. Itong huli, partial ay, partial x. So, partial x, ito lang. So, this is negative partial x. Tapos, yung direction niya ay k hat. Bale, ano to? Ano ang partial x neto? Plus minus mu naught k over 2c. Tapos, may negative. So, ayan. Then, yung derivative niya ay minus plus k hat. Parang yung ginawa lang natin dito kanina. Di ba may minus plus tayo na ano? Ay, saan na yun? Ito. Nang nag-derivative tayo sa absolute value, may minus plus. So, yun din yung gagawin natin dito. Then, yan lang ba yung x derivative, no? Kasi constant lang to. Magva-vanish yan. This is equal to mu naught j. And then negative, kasi may negative ka. Mu naught epsilon naught. Tapos anong partial t neto? Mu naught k c over 2 k hat. Yan lang siya. Ito lang yung magka-count partial t. Ito wala yan. So, treated as constant, to mawawala siya. Mu naught kc over 2 lang yung meron tayo. Now, bali, medyo nakakalito tong sign kasi negative, tapos plus minus, minus plus. Ito yung plus minus, ito yung minus plus. So, ang product neto ay negative, negative. Kasi ito ay negative, ito ay negative. Therefore, positive na yan. Positive na yung mga plus minus sign natin. So, convenient na nawala siya. Mu naught K over 2C K hat equals mu naught J plus, minus, tama ba? Partial T. So this is bakit? Teka lang class parang may nawawalang negative sign. Bali ito ay mu naught J minus mu naught epsilon naught mu naught KC over 2 K hat. Bale, ang meron tayo, ano to? This is yung mu naught plus ang ating C, ang mu naught epsilon naught I, teka nga lang, C is 1 over square root of mu naught epsilon naught. Bale, ang mu naught epsilon naught equals 1 over C squared. Yan yung ating, so ito, magiging 1 over C squared na yan. Bale, this is equal to mu naught K over 2C K hat equals mu naught J minus mu naught K over 2C K hat. So, meron na tayong J. Cancel natin yung mga mu naught na natira. So, J now equals, wait, dapat mag-0 to eh. Teka lang class Saan siya, itong negative dapat mawala. Dapat mawala yung negative sign. Wait lang class. Wait nga lang. Na-pause pala yung recording. Bali yung ginawa natin class, ito, yung 'di ba may negative tayo diyan, binura lang natin kasi na-doble ko pala. Itong minus absolute value of x, ito na 'yon. Yung dalawang cases. Kaya minus plus yung meron dito. Then magbabago na rin to, minus plus, minus plus. Then in the end, meron kang negative mu naught k over 2c. On the right side, meron ka ring negative mu naught k over 2c. Therefore, yung j mo, 0. So, anong ibig sabihin nun? Lahat ng recap natin. So, for absolute value of x greater than ct, rho is 0, j is 0. For absolute value of x less than ct, meron tayong rho is 0, j is 0. So, tignan nyo, medyo weird siya kung wala kang charges and wala kang currents dahil meron kang potential. Hindi naman 0 ang potential mo everywhere, di ba? Meron kang A. Meron kang A na non-zero. So, ano yung last step? Di ba? Step 1 is find E and B. Step 2, find rho and J. Step 3, check for discontinuities. Check for discontinuities in V and A. Yan yung last step. Kasi medyo, para lang ma-ensure natin kung tama ba yung rho and J na na-calculate natin. Bale, ang discontinuities na meron tayo, for V, wala kasi 0 yan everywhere. Ang A, may discontinuity ka at absolute value of x equals ct. So, absolute value of x equals ct. May jump. Diba kasi nung una, 0, pero bigla ka nagkaroon ng value. So, may discontinuity at the vector potential. Now, for V, 0 everywhere. No discontinuity. Now, for A, there is a discontinuity. So class, kung may discontinuity sa vector potential, dapat meron tayong source. There must be a current source somewhere. Pero nasan yon? Kasi 'di ba ang findings natin, rho and J are zero everywhere. Paano pa natin ito papalitan? Tama naman yung steps na ginawa natin kanina. Bale, ang gagawin natin, i-investigate natin yung boundary. So at the boundary, i-recall lang natin yung boundary conditions. Class high yung 4. Lagi natin itong sinusulat pero ulitin ko lang. Equals sigma F. So ito yung discontinuity ng electric field. Ito B1 perpendicular, B2 perpendicular equals 0. Third condition, E1 parallel minus E2 parallel equals 0. And fourth condition, 1 over mu1 B1 parallel minus 1 over mu2 B2 parallel equals KF cross n hat. Class, yung mga perpendicular at parallel, depende na yan sa boundary surface na meron kayo, ha. So, bali ang concern natin, class, is yung magnetic field, yung vector potential. May discontinuity dito. So, kailangan natin ng source, pero hindi natin alam kung nasan. Gagamitin natin to. Ito ang boundary condition 4. So, bali, meron kang source somewhere, pero hindi natin alam kung nasan. So, let's use that. 1 over mu naught. Yung B1 natin, let's say yung B1 natin, teka lang, class. For ano to? Ayan, nasa na yung magnetic field natin? Ito yung ating magnetic field, di ba? If negative for x less than 0, I greater than 0. Positive for x less than 0. So, ang gagawin natin, ano natin yan? I-minus natin. Bali, meron tayo 1 over mu naught k over 2c ct minus absolute value of x j hat minus yung negative 1 over mu naught k over 2c ct minus absolute value of x j hat equals k cross n hat, where k is your surface density, surface current density. Tapos at the boundary, di ba? Nasaan ba yung boundary? At x equals 0. Yan yung ating boundary condition. Now, yung mu naught mawawala. Tapos mag-a-add lang yan dalawa. Yung x mawawala na rin yan kasi 0 yan. Balik k over 2c plus k over 2c equals k cross n hat. Class, itong k na hindi vector constant, ha. Ito, k na vector, surface current density yan. So, may CT pa pala. CT. Ayan. Therefore, KT, dalawang 1/2 magiging 1 yan. KTJ hat equals K cross N hat. Bali, pwede na nating malaman, class, kung ano yung K natin. So, what is, ang tanong muna, what is N hat? Diba, ang boundary natin, is x equals 0. Bali, class, ang meron tayong x, y, z. Ang boundary natin nasa x equals 0. So, ito. Diba, x equals 0 yan. yung YZ plane. Therefore, N hat is I hat. Kasi ito yung ano natin, ito yung normal natin. I hat yung kanyang normal vector. Now, ang mangyayari, KT J hat bale equals K cross I hat. Now, ang K natin, ano bang unit vector na kapag kirinos mo sa I, magiging J? So, ang Z, ang K hat, kapag kirinos ko sa I, magiging J. So, bale, ang K natin, KT, K hat. Medyo no? Nakakalito. Ito ay yung surface current density. Ito yung given na constant. Ito yung unit vector along Z. So, yan na yung ating current source. Now, ang conclusion natin dito, so even though the volume current density J is 0 at X not equal to 0. Ayan. There is a surface current density. So there is a surface current density at X equals 0. Bale, ang K mo, ito ay KT, K hat. Diba? Yan yung ating surface current density. Or, kung gusto mo siyang gawing J, edi KT Dirac delta of X, K hat. Kaya, nagiging 0 siya kasi, di ba ang Dirac delta of X, 0 everywhere except at the origin. So, everywhere except at 0, 0 yung J natin. Pero at that position, at X equals 0, meron kang surface current which is equal to KT, K hat. So, yan na yung yung sources, rho and J, that would give rise to this potential. Diba? Medyo siya, medyo mahaba yung steps. So, step 1, ayan, kaya in-outline ko siya, find E and B. Step 2, find rho and J. Step 3, check for discontinuities. Ayan, para mag-guide kayo. Tapos class, ang isa pa nating mapapansin. So, notice that for X, absolute value of X greater than CT, the fields are 0. Diba? For absolute value of X is greater than CT, 0 yung E and B natin. Nasaan na yan? Ayan. So class, bakit siya 0? Kasi yung class, ito yung speed of light. Ito yung time na nag-travel siya. Bale, kung ito yung distance na travel ng light mo, ito siya. Tapos hahanapan mo siya ng electric field dito. 'Di ba? Absolute value of X should be greater than CT. Tapos hahanapan mo siya ng field dyan, malamang wala ka pang makikita. Kasi yung information mo nandito pa lang. So yung electric and magnetic field information natin, magta-travel yan at the speed of light. So at a distance CT, ito pa lang yung na-travel niya, pero hinahanapan mo na ng electric field dito. Hindi, kaya 0 yon. Kaya 0 yung mahahanap mo. So the fields are 0 since the information has not yet arrived. So may clue na tayo na yung speed limit ng ating information ay hindi lalampas sa speed of light. So 'di ba? Related 'yan sa relativity, which is pupunta naman tayo sa other time. Pero in the meantime, ito muna yung example natin. So any questions, class? Si Angela May.
Wala naman po, sir.
Okay, si Ansley.
Wala pa naman po, sir.
Okay, si Axel.
Wala rin po, sir.
Okay, si Bea. Any questions?
Wala rin po, sir.
Sige, wala namang tanong. Sure kayo class sana naintindihan nyo. Ang important lang dito is ayan, yung dating alam nating E is negative del V napalitan na. Pero yung B is del cross A consistent pa rin. Yun lang naman yung key learning dito. So let's move on to the next topic, which is the gauge transformation. Medyo ano na to class, medyo mathematical na siya. Yung mga ginagawa natin. Nasa dulong part na tayo. Nasa dulong part na tayo ng book. So medyo ano na siya. Medyo mas mahirap compared sa una. So now, dito class sa gauge transformation, 'di ba ang gagawin natin dito, mag-i-impose tayo ng extra conditions. So here, we are free to impose extra conditions on the potentials V and A as long as nothing happens. As long as nothing happens to E and B. So, class, ang gagawin natin sa gauge transform, itong V, isi-shift natin yan by some value. Yung A, isi-shift natin by some value. Pero wala tayong babaguhin sa A and B. So yung task natin, maghanap tayo ng alternative V and A such that same result yung makukuha natin sa E and B. Now, suppose we have some electric potentials V and V prime. Sabihin natin V prime, which then correspond to the same electric field. So bali ang meron tayong dalawang potential, electric potential V and V prime, pero ang resulting electric field same lang. Tapos also suppose sa magnetic field naman, we have the vector potentials. A and A prime. Tapos same din yung magnetic field na ibibigay nila, which correspond to the same magnetic fields. Same magnetic fields. Bale, ang tanong, ano yung relationship ng V and V prime at saka nung A and A prime? So, ang gagawin natin, we relate them by the following. So, ang A prime natin, let's say yan ay A plus some vector alpha. So, ito yung bagong vector A. Di ba itong vector potentials na to, same magnetic fields ang binibigay nila. Tapos yung relationship nila, pwede nating isulat as may dinagdag ka lang na some value sa A. Tapos, yung V prime natin, yan ay obtained by V. Tapos dadagdagan natin siya ng some value beta. Hindi natin alam to Hindi natin alam to. Hindi natin alam yan. Pero ang alam lang natin, yung A at A prime, they correspond to the same magnetic field. Ang V prime at V naman, they correspond to the same electric field. Now, let us first calculate the magnetic field. So, paano makuha yung magnetic field? Di ba del cross A lang? So, del cross A prime, itong both sides natin, this should be del cross A plus alpha. So, del cross A prime equals del cross A plus del cross alpha. Pero class, di ba, ito yung magnetic field. Ito yung magnetic field. Dapat same lang sila. Therefore, itong quantity na yan, this should be 0. 'Diba? Kasi ito na yung magnetic field na magre-result from the vector potential A prime. Ito yung magnetic field na magre-result from the vector potential A. Since equal sila, dapat mawala to. Therefore, we have del cross alpha should be 0. Again, kapag ang curl ng isang vector ay 0, we can write it as a gradient of a scalar. So itong vector na to, yung alpha, pwede natin yang isulat as a gradient of some scalar quantity. So let's say alpha equals gradient of lambda, where lambda is another quantity na naman, hindi na naman natin alam. So in the meantime, isulat natin yan. Next, let's calculate the electric field. So calculate E. 'Di ba ano yung E natin? Negative del V minus partial A partial T. Yan na yung bago, 'di ba? So bale, ito, let's calculate the electric field for this one. Negative del V prime. Ano to? Ay, wait nga lang. Tama ba? So minus partial A partial T. This should be negative del of, wait lang class, V plus beta. So kunin natin yung gradient ng both sides. Ay, tama lang. This is negative del V plus beta minus partial T ng A plus alpha. Plus itong left hand side is yung bakit V prime? So this is V lang. Ito yung luma, ito yung shifted. So mapapansin natin, dapat yung electric field nila dapat equal, di ba? Ito yung electric field ng luma, ito yung electric field ng shifted. So dapat same lang yan, kaya equal sign. So ano to? Negative del V mawawala na yan. Tapos yung partial A, partial T mawawala din. Ayan. So 0 equals negative del of beta minus partial alpha partial T. So i-rewrite, ilagay natin sa kabila, del of beta plus partial T ng ano to? Ng alpha. Pero class, ano ang alpha? Yun ay del of lambda. So del of lambda, this should be equal to 0. So yung gradient, i-ano natin yan, i-group natin. Gradient ng beta plus partial lambda partial T equals 0. Therefore, gradient of something is 0. Yung something na yun, 0 din. So beta equals negative partial lambda partial T. Ito na yung pangalawang unknown quantity na meron tayo. Therefore, yung pag-shift natin, yung gauge transformations, we have A prime, ano yan? A plus alpha. Pero ano yung alpha? Del lambda. So A prime is A plus del of lambda. And ano yung isang transform? V prime equals V plus beta. Pero ang beta natin ay negative partial lambda partial T. So V prime equals V minus partial lambda partial t. Class, itong dalawang to, these are the gauge transformations. Bale, ang ginagawa natin dito, class, sometimes medyo pangit. Medyo pangit yung A and V na meron tayo. So, ang gagawin natin, pangit yan. So, pangit to. Maglalagay tayo ng some value para makakuha ng bagong A that will yield the same magnetic field. On the other hand, yung potential natin na medyo yung ayaw natin, mag-shift tayo ng ganitong value para makakuha tayo ng bagong potential such that same pa rin yung electric field na makukuha natin. Yun yung use ng gauge transformations. So para ma-appreciate nyo siya, mag-ano tayo, example tayo. So example 1, find the fields charge and current distributions. That correspond to the following. V of xt equals 0, tsaka A of xt equals negative 1 over 4 pi epsilon naught qt over r squared r hat. So, class, yung mga ganitong klaseng potential, hindi tayo familiar, no? Ito, zero potential. Zero electric potential, pwede. Pero yung vector potential na qt over r squared r hat, medyo ano siya, hindi siya familiar sa atin. Kasi ito, di ba, ang familiar tayo nito sa electric field, kq over r squared. Pero bakit napunta siya sa vector potential? So, ang gagawin natin, let's find the electric field. So, di ba yung tanong, find the field, charge, and current distributions. So, recall natin that the electric field equals negative del V minus partial A partial T. So, bale, dali lang yan. 0 minus negative 1 over 4 pi epsilon naught partial T edi Q over R squared, R hat. Edi yung electric field mo, 1 over 4 pi epsilon naught Q over R squared, R hat. So, familiar na yan, di ba? Siya na yung electric field na alam natin. Electric field ng point charge, kq over r squared r hat. So, this is electric field of a point charge. Pangalawa naman, B equals del cross A. So, B equals del cross A. Pero class sa spherical, mag-shortcut na ako sa curl, ha? This is 1 over r, 1 over sine theta, partial AR, partial phi, ano to, theta hat, minus 1 over r, partial AR, partial theta, phi hat. So, partial phi and partial theta, wala naman, di ba? Partial r lang siya. Bale, yung curl natin, 0, and therefore, the magnetic field is 0. Now, ano yung charge distribution na magko-correspond sa point charge natin? Edi rho equals Q delta cube of x. Diba point charge natin ay delta x, delta y, delta z. Or we can write it as delta cube of x. On the other hand, ano ang current density na magko-correspond sa zero magnetic field? Edi 0. So yan na yung ano natin. Corresponding electric and magnetic fields and corresponding charge and current distributions that will result to this V and this A. Pero itong pangalawang tanong, magagamit na natin yung gauge transformation. So question 2, use the gauge function. Ano tayo? Lambda equals negative 1 over 4 pi epsilon naught qt over r to transform the potentials. Bale, ito yung gauge transformation natin, di ba? So, mag-add lang tayo niyan. Bale, ang V prime natin equals V minus partial lambda partial T. So, ano yung original na V natin? 0. 0 minus partial T neto, negative 1 over 4 pi epsilon naught Q over R. So, bali ang V prime natin is 1 over 4 pi epsilon naught Q over R. So, ito na yung potential ng point charge, di ba? Tignan nyo, class. Yung potential natin, 0. Pero yung electric field natin, point charge. Medyo weird siya sa unang tingin. Pero nung nag-gauge transform tayo, ang potential mo, mukha na siyang point charge. So, naging okay na siya. Hindi na siya medyo nakakalitong tignan. Tapos, yung A natin, yung A prime, this is A plus del lambda. Tama ba? Yan yung pangalawa nating gauge. Ay, hindi. Ay, oo, tama. Del lambda. So, this is, ano yung unang A? 1 over, negative 1 over 4 pi epsilon naught qt over r squared r hat plus, ano to? Plus yung gradient is simplify ko na ha. Partial lambda, partial r, r hat. So, ano yung partial lambda, partial r? This is positive 1 over 4 pi epsilon naught. Negative 1 over 4 pi epsilon naught qt over r squared r hat. Ito ay, di ba, negative 1 over r squared. Pero may negative ka dyan. So, positive 1 over 4 pi epsilon naught qt over r squared r hat. So, A is 0. A prime equals 0. Yan na yung ating bagong V and bagong A. Kung mapapansin nyo, medyo normal na siya. Medyo normal na. Kasi class ang point charge, di ba? Ano lang siya? Wala ka namang current source. Wala ka namang vector potential doon. So, 0. 0 yung A prime. Pero yung V prime mo, meron na. So, balik kapag kukunin nyo naman yung E and B, i-mental nyo na lang. E is 1 over 4 pi epsilon naught Q over R squared R hat. Hindi pa rin magbabago. Dito naman, B is del cross A, 0 pa rin. So, kahit na binago natin yung V and A, naging V prime at naging A prime, hindi pa rin magbabago yung E and B. Yun yung kagandahan ng gauge transformations natin. Okay, class, may questions ba? Si Kalista, may tanong ba?
Wala pa po, sir.
Okay, si Easy Franco, may tanong ba?
Wala naman po, sir.
Si Jessica, any questions?
Wala naman po, sir.
Okay, kung walang tanong, then anong oras na? Sige, proceed na tayo sa next topic. So, medyo short na lang to dahil magta-time na. Bale, class, yung naintindihan nyo naman yung gauge transformation. Nagsishift lang tayo para maging maganda yung form. Pero, same electric and magnetic fields pa rin yung makukuha natin. Meron tayong dalawang gauge na important actually. First, we have the Coulomb gauge. Sa Coulomb gauge, del dot A is 0. Ito ay makikita natin sa magnetostatics. Tapos class, ang mas important na gauge transform na gagamitin natin is yung Lorentz gauge. Sa Lorentz gauge, del dot A equals negative mu naught epsilon naught partial V partial T. Class, mga transform lang to ha. Wala tayong ginagawang something special. Nagdadagdag lang tayo ng mga extra terms. Pero yung result natin sa electric and magnetic field same pa rin. So, ano ba ang kagandahan netong Coulomb gauge and Lorentz gauge? So, i-recall natin class yung yung quote-unquote Poisson equations na bago. So yung Poisson equation natin, yung, di ba dalawa yon? Yung una, del squared V plus partial T ng del dot A equals negative rho over epsilon naught. Using the Coulomb gauge, del dot A is 0. So dahil sa Coulomb gauge, magiging 0 yan. Therefore, del squared V equals negative rho over epsilon naught. Ito yung sa electrostatics class, di ba? So sa Coulomb gauge, the potential is easy to calculate. Yun lang yung ibig sabihin nito sa Coulomb gauge. Kaya napapadali yung buhay sa electrostatics. So ito yun, dahil sa Coulomb gauge. Pero ang problema dito, hindi madaling isolve yung vector potential actually. Kasi sinet mo ng 0 yan, paano mo na siya makukuha? Diba? Kaya gagamit tayo ng Lorentz gauge. Mas ano siya, mas may use yung Lorentz gauge natin. So yung pangalawang class, yung pangalawang Poisson equation. Teka, balikan ko nga. Saan na yung itong Poisson equation na to, yung pangalawa. Di ba ito yung una? Ito yung pangalawa na Poisson equation na gagamitin natin. So that is, del squared A minus mu naught epsilon naught partial squared A partial T squared minus del of del dot A plus mu naught epsilon naught partial V partial T equals negative mu naught J. Ito yung pangalawang Poisson equation na meron tayo. So, bale, ang gagawin natin, yung Lorentz gauge. Diba, sa Lorentz gauge, del dot A is negative mu naught epsilon naught partial V partial T. So, ito, negative mu naught epsilon naught partial V partial T. Therefore, magzi-zero out to kasi negative, positive. 0 na yan using the Lorentz gauge. Therefore, meron tayong del squared A minus mu naught epsilon naught partial squared A over partial T squared equals negative mu naught J. So, i-box lang natin to. Ito na yung simplified na natin na Poisson equation. Let's label this star. Tapos yung ito, 'di ba, gumamit tayo ng Coulomb gauge. Pero let's say Lorentz gauge yung gagamitin natin. Therefore, hindi na to 0. Ang meron tayo, del squared V plus partial T ng del dot A equals negative rho over epsilon naught. Diba? Yan yung Poisson equation natin na una. Pero sa Lorentz gauge, del dot A is negative mu naught epsilon naught partial V partial T. So del squared V plus partial T ng negative mu naught epsilon naught partial V partial T equals negative rho over epsilon naught. Dahil ito sa Lorentz gauge. So simplify natin yan. Ito class partial T, So magiging partial squared T yan. Bale, del squared V minus mu naught epsilon naught partial squared V partial T squared equals negative rho over epsilon naught. So let's label this double star. So gawin nating double star yan. Class, tignan nyo. Yung unang star, del squared, tapos minus partial squared partial T squared. Pangalawa naman, del squared minus partial squared partial T squared ulit. So yung operator natin sa una at pangalawa, pareho lang. So let's note that we have the same differential operator. In star and double star. Ano to? 'Di ba yung del squared minus partial squared partial T squared? Yun yung differential operator natin. So now, we will define the D'Alembert-Version. Tawag sa differential operator na yan ay the D'Alembert-Version. So, yan ay denoted by the square. Medyo weird siya. Squared equal, that is defined as del squared minus mu naught epsilon naught partial squared partial t squared. Yan ay yung differential operator natin. Therefore, yung ito, D'Alembert-Version yan, acting on A. Pangalawa, D'Alembert-Version acting on V. So we can generalize them as equation 1, del squared V equals negative rho over epsilon naught. Pangalawa, D'Alembert-Version A equals negative mu naught J. So class, di ba? Mas elegant siya. Itong mga equation na to, pangit na versions yan ng Poisson equation. Yung, ayan, pangit na version yan ng Poisson equation. Tama, pero mas simple. Etong una, di ba mukha lang siyang Poisson equation sa electrostatics sa del squared V equals negative rho over epsilon naught. So, yung ginawa lang natin dito, in-extend lang natin siya to electrodynamics. So actually, this is sometimes called the four-dimensional version of Poisson equation. Kasi, di ba yung Poisson equation, x, y, z, three-dimensional lang. Ito, nagkaroon ka ng temporal na derivative, yung partial t. Kaya, four-dimensional na siya. Therefore, mas elegant. Mas elegant na yung equations natin. So, yun yung kagandahan class ng gauge transforms. Hindi nagbabago yung electric and magnetic fields, pero you can reduce them into simple equations. Yan. Okay, class. May tanong ba? Wait lang. Si Noel, Denise.
Wala naman po, sir.